Okay, thank you, Thomas. Yes, so Daniel has her presentation about both sides of the scale distribution, both low scale and high scaled. But I want to divert all your attention to the other end of the scale distribution, the high scale distribution in United States. So just to give you an idea how large is the size of skilled immigrants in United States. So I produced this following graph to show you how large is the size of skilled immigrants in United States. If you look at the bottom blue line, that's the fraction of immigrants in United States high-skilled labor force. So by high-skilled labor force, I defined those at least with a bachelor's degree. This number started in 1994, a little bit lower than 10%, and now it's on this slow growing trend, approaching more than 10%. And another important feature of skilled immigrants in the United States is that they are unevenly distributed across occupations. If you're looking at the top green line, that's the fraction of immigrants in computer scientist-related occupations. This number started a little bit above 10%, but if you're looking at nowadays, more than 25% of the foreign computer scientists who are working in the United States are actually foreigners. And the other STEM occupations, they are concentrated, generally speaking, in the STEM occupation, science, technology, engineering, and mathematical occupation. So in the middle red line, I plot the number of immigrants in the other STEM occupation except for computer scientists. This number is fairly high. Yesterday, our keynote speaker, David Cardigan, mentioned that if we assume there is a perfect substitution between native and foreign labors, and that there is a downward sloping labor demand curve, then almost by construction, we will find out there is a negative impact of immigrants on domestic workers. And my research question is this still true for the high-skilled labor market? So this paper is going to answer the following questions. I'm going to study a specific market, STEM occupations in United States for high-skilled workers. I want to see what exactly the impact of immigrants on those native workers. Then the next question is, I want to move a little bit further. How do native workers respond to this foreign labor competition? There is literature about geographic mobilities, so people move to different locations, labor market. But I would like to study another adjustment margin, which is the occupational mobility. So the idea here is fairly simple and straightforward. There are unbalanced inflow of skilled immigrants, so the wages, market wages, will be changed differently. As a result, the forward-looking immigrants will respond, the forward-looking natives will respond to this by choosing different occupations. That's the adjustment margin I'm focusing on in this paper. And I might be a little bit ambitious. What I want to eventually see is what is the welfare impact and what is the implication of this model. So to give you a general idea without introducing a model, let me tell you what I do in this model. In this model, it's a general equilibrium model with a dynamic discrete choice. So from the labor demand side, I model the people's occupational choice, native workers' occupational choices. The labor supply, let me start with the labor demand side. So from the labor demand side, I have occupation-specific production function. And this production function is general enough to allow native and foreign workers to be substitutes or even growth complements. This is different from previous literature, because previous literature, people usually assume, oh, they are perfect substitutes. Let's think about how the curvature of the demand curve, then we will figure out what is the negative impact. There are some restrictive assumptions made in their study. So what I want to do is, rather than make any assumptions, let me estimate the production function from the data. So I will estimate the occupation-specific production function, which captured the possibility of them being like imperfect substitutes or complements. And this production function is also occupation-specific. So different occupation has different production function, which captured the asymmetricities across different occupations. And from the labor supply side, I'm focused on the native workers' human capital accumulation process, their decisions. So this is, in essence, a dynamic ROI model, and they accumulated occupation-specific human capital. They also respond to these changes in market price. And this paper, I want to briefly mention some of the important papers in this literature. my paper falls into the native response to foreign immigration shocks. And I would consider my mechanism as an analog to the geographic mobilities. So for high-skilled workers, they are more likely to move across geographic locations. So I think it's more relevant to study this occupation market. And there are only 2 structural papers in the literature trying to study the mechanism behind this. So one is the Bond 2015 paper and the Lau 2017 paper. How does my paper differ from their paper? Bond paper is in essence a partial equilibrium model, only focus on one occupation group. While my paper, I'm trying to incorporate more than one occupational groups. So I'm trying to see these migrations across different occupations. How does this help the local labor market to absorb any shocks from immigration shocks? And my paper differs from Lau's paper because Lau's paper is more like a vertical response from native workers, like occupational choices. So he looked at the blue collar worker and white collar worker, while I mainly focus on the high skilled. It's more like a horizontal shift of your occupational choices. So just in case I don't have enough time to finish the presentation, let me give you the preview of the results. So what I find is, when I estimate the data, I do find that there is imperfect substitutabilities between native and foreign workers in some occupations. For example, computer scientist occupations. And what is more surprising is, I find that there could be complements in the other STEM occupations. What does complements means? That means if there is more inflow of skilled immigrants, actually the native workers benefit from this. Then I go to the Innate data set trying to study what is the micro foundation of this difference across different occupations. And then with this estimated model, I can do several counterfactual, which is pretty interesting. The first one is I want to answer the question, when we observed the large inflow into the United States over the past 20 years, how large is the effect of native on native workers' wage? So I find that limited wages compared with the previous literature. And with one advantage of this multiple sector equilibrium model is you can do simulations, evaluate the policy impact of a selective immigration policy. I do find that selective immigration policies can significantly improve the welfare of domestic workers. So let me briefly talk about the policies in the United States in terms of high-skilled immigrants. Unlike the Canadian, which is a point-based system, in United States, if you as a skilled worker want to enter the US labor market, you have to go through this H-1B visa program, which is established by the Immigration Act of 1990s. And this is a program targeting high-skilled immigrants. So virtually all the beneficiaries from this program have a bachelor's degree. And this is a pretty straightforward, strictly enforced program, which means if you can only stay here for a maximum of 6 years. After that, you have to either switch to a permanent status or you have to leave the country. And another important features of the programs is there is a sponsor firm. It's an employer-based program. So there is a sponsor firm that is going to sponsor you for these types of visa. So immigrants are kind of tied to their sponsor firm, tied to their occupations. And there is a cap on this H-1B visa, which means there are more people trying to get the visa, but which is restricted by the cap. A lot of firms may not be able to retain those workers because of the visa. So these programs provide me some of the plausible exogenous variations I need for the identification part. Let me briefly talk through you what is the model. The model is at age 22. That's the usual age when high-skilled workers enter the labor market. So they enter the labor market with a type of, I call it innate ability, from a flexible specified bivariate normal distribution. And even though I call it innate ability, since it starts at age 22, it also captured all your previous educational investment. And based on this, that's their innate ability. Based on their ability, every period, individual within the STEM occupation have two choices, either to choose work as a computer scientist or the other STEM occupation. So this is a very simple binary choice model. The reason I'm doing this is because if I include the 3 digits like occupations, I ran into small sample problems. That's why I choose only to model those 2 groups. And the computer scientists count for 50% of, approximately 50% of the beneficiary of H1B, the STEM occupation. So that's why I try to divide them into those 2 large groups. And when you're working in one occupation, you also accumulated occupation-specific human capitals. This is only partially transferable across different occupations. And this imperfect transferabilities between occupations act as a friction to occupational mobility. And also, this is a very simple model. There are lots of other randomness which cannot be captured by this human capital process. So I include a taste shock every period. And this taste shock is also age-specific, because empirically, I observed from a panel data, the young workers are significantly more likely to switch occupations compared with the more experienced workers. Then the whole decision period ends at age 65. So individual's human capital, as I mentioned, is occupation specific. So your human capital function actually is a function of your tenure in your current occupation and your tenure in the other occupation and your innate ability, including your previous educational investment. And I also assume there is no market friction. Then the wages are determined by multiplying your human capital with the market equilibrium price for this human capital function. Then the flow utility function, that's the utility individual get from every period, equals to the wages for the other STEM occupation and equals to the wages plus the taste shock for computer scientists. Essentially, I could have taste shock for both occupations, but for the identification part, I could only identify the difference between those 2 taste shock. That's why I choose to model that as a taste shock in one sector. And the decision process of the agents can be defined by the following Bellman equation. So the value of working as a computer scientist today depends on first your wages this period plus your taste shock. That's your flow utility from this period. And your career perspective prospects in the following remaining years of your work life. And the individuals based their decisions on a lot of things, right? For example, the future immigration inflow, the future technology shock, so this is a whole dynamic thing, their decision taking into consideration of the future changes. And every period, the individual will choose which occupations give them the highest utility. And that's individual occupational decision or the labor supply decision. If I aggregate across all the individuals, I will have the total labor supply. And for the labor supply, of course, there are a second type of labor, which is the immigrant labor, labor supply by immigrants. So what I will do is, I'm simplified this side a lot. I take the immigration supply, labor supply directly from the data. So I back it out from the data. So let me spend some time to talk about the labor demand side, which is the side I relax the most from the previous literature. So I use this flexible enough CES production function, and which means any firms or treat those 2 types of labor, native and immigrants, 2 different types of labor. They are not perfectly substitutes. The rho parameter here captured their substitutability. And I also estimate the curvature of the production function from the data. So which means I also allow the constant return to scale, as also mentioned by David Carter yesterday. And the equilibrium is for every period of every occupation, there has to be an equilibrium supply of labor and demand. That's basically the model. Let me show you some of my results. So I estimated the model using simulated method of moments, and all the data I use is public available survey data. And for the time of sick, for the time, I will not go into the identification of this paper. This is a paper of quantitative exercise. So I make sure I have a clear identification. So if you're interested in the identification of this model, we can talk after this. So let me introduce you some of my results here. I think the interesting thing is if you look at the computer scientist sectors, the computer scientist sectors like value your experience as a computer scientist. Also, it values your experience in the closely substitute occupations, the other STEM occupations. But to a less extent, the difference is not so huge, which kind of reassuring to me there are some like mobilities. There is some mobilities across those two occupations. And I also find that there is a negative correlation coefficient between the innate ability, which means there is a positive selection into two occupations. Unlike Daniel's paper yesterday, Daniel has this type of negative selections. My paper has a positive selection. So of course, they are in different contexts, but I find that there is a positive selection in both sectors, which means the best computer scientist goes to the computer scientist sector, and those workers who are good at the other STEM sectors move to the other STEM sector. So this is the most interesting result comes from. My most interesting result comes from the labor demand side. So actually, whether they are substitutes or complements really depends on the ratio of psi over rho. That's the curvature of my production function over the substitutability between native and foreign workers. So if this number is greater than 1, that means there is complementarity. The inflow of foreign immigrants will actually increase the wages paid to domestic workers. So that's the ratio between my third line over the second line. So if you quickly look at those numbers, I find that this number is smaller than 1 for computer scientists occupations. But this ratio is greater than 1 for the other STEM occupations. So which means, okay, for computer scientists, there are imperfect substitutes. But for the other STEM occupations, there are complements. Once I find this result, I really want to find what is the micro foundation of this? What possibly drives the difference between those two occupational groups? That's why I start to check the Innate dataset. Innate dataset provide different measures of tasks being performed by each occupation. So this is a suggestive evidence. So if you look at the chemical engineering, that's the other STEM occupations. And this radar graph is the task space of a specific occupation. And if you look at the inner one is the computer programmer, which is the computer science occupations. For computer scientists, it's almost like all the tasks, majority of the tasks being performed is the mental task, which is the cognitive task. While you compare it with the chemical engineering, the other STEM occupations, this occupation expands this task space more evenly. There are a lot of interactive tasks required by this occupation. So I want to borrow the idea of international economics, the specialization idea to here. If more tasks are being used here, which means this gives the workers a possibility of specialization in different tasks, even within an occupation. So the idea here is, okay, if we use more of the task space, native chemical engineers will specialize in writing reports, communicate with customers or their subordinates. Why the immigrants are going to specialize in these cognitive stuff. So if they can specialize within an occupation, they shift out the production frontier that could possibly be the source of complementarity. So with this estimated model, I can actually do a lot of simulations to answer some interesting questions. So the first question I want to answer is, how large exactly is the impact of large inflow of skilled immigrants into the United States? So what I did here is I restricted the number of computer scientists that enter United States to its 1994 level and to see how that is going to change the wage and the employment choice of domestic workers. I only restricted the number of computer scientists is I want to compare it with the Bond paper, which their paper only focused on the computer scientist sector. So if you look at those numbers, you will figure out that my estimate is smaller, about 1/3 to 2/3 compared with Bond paper. The primary reason is, I've already mentioned, Bond assume they are perfect substitutes, and I allow them to be imperfect substitutes or even complements. So the lack of substitutabilities between native and the foreign workers, that could contribute to this muted and smaller impact of inflow of skilled immigrants. And my model, I also have a human capital component in it. So that's why those human capital is occupation specific. It acts like a friction to mobilities. That's why I also find a smaller impact on employment level. And I also interested in some like policy relevant questions, because in Canada, our immigration policy system is point based. So it's kind of like a selective immigration policies. It favors people with specific task skills, where they have specific education. But for United States, the high-skilled immigrants, it's more like if you got it, it's employer-sponsored. So I want to, and they have a total cap on the number of visa that can be granted every year. So I want to compare those two types of immigration policy, which one can achieve a higher welfare impact. So I compared the total, a cap on the total number of skilled immigrants versus a selective immigration policy. I find that for this selective immigration policy, remember, the selective immigration policy, I only restricted the number of immigrants in computer scientist sector to its 1994 level because there is an imperfect substitutabilities in this sector. I allow the number of workers in the other STEM sectors to come into the United States as in the data. There are more immigrants in the lower counterfactual economy, but actually domestic workers are benefited from more immigrants as long as those immigrants coming into the United States working in the occupations where complementarity exists. So by this, they earn more, the economy as a whole can benefit more. That's my argument here. I find the selective immigration policy can actually benefit the domestic worker more as opposed to a total cap on skilled immigrants. And I'm also interested in something related to the mechanism, because I argued so hard in this paper that the occupational mobility is an important margin. But how important the margin from the individual perspective? So I want to see if I restricted people's occupational choices, how bad they will be. What I did in this part is I let the immigrants enter the United States as in the data, but I restricted the native workers. They cannot switch occupations as a benchmark. So if they cannot switch occupations, they cannot undo any immigration shocks. As a result, so they will be negatively impact. I compute the CVs only for 6-year temporary restrictions. Their lifetime income will be negatively affected by 15,000. And think about if this is a permanent restrictions, there will be larger negative impact as well. So the idea here is I want to push to the direction if you want to help those native workers, maybe education to provide them on-the-job training, and that will help them more because that will help them to avoid the direct competition, find employment in other occupations where they can earn a higher salary. That's the purpose of this exercise. So my time is almost up. Let me summarize what I find in this paper. In this paper, I studied the native workers' behavior response, their occupational choices in response to foreign labor shocks, the foreign labor supply shock. And I identified occupation mobility as an economically meaningful adjustment margins. So this adjustment margin will help to mitigate and diffuse any initial impact of the foreign labor competition. And I also find interesting result in terms of the substitutability and complementarities across different occupations. And compared with previous literature, because of the model, I find the limited negative impact of this large inflow of immigrants into the United States. That's basically what this paper is about. So let me just add one thing. This paper is about occupational mobility, how people change their occupation in response to the immigration shocks. So I also realized that education is an important adjustment margin. So I have an ongoing project which talk about this type of immigration policies, focusing on the labor market. How does those immigration policies are going to reshape the US higher educational systems? That's my new project. That's going to looking at another like adjustment margin. Okay, thank you. That's my project.